So I'm supposed to be showing that this left side equals 1. It's a sine of x. It's weird that it's squared. We didn't spend a lot of time with this. It was just homework questions that had this come up. But for sure, if it's sine of x and it's cotangent of x and secant of x, all of those, x is an angle. So I'm going to go ahead and just label from this angle, I'd have an opposite leg, I'd have an adjacent leg, and I'd have a hypotenuse. This notation is not super common until you get to upper level math. It is just saying I have the sine of angle x, that value is being squared. Which means, since I know sine is opposite over hypotenuse, I am saying I have an opposite over a hypotenuse, and it's being squared. So maybe 3 over 5 or 8 over 17, just two numbers that are being squared. Likewise, cosine squared would be the adjacent leg over the hypotenuse that's being squared. And when you square fractions, you're squaring the top and the bottom. So I'm just going to go ahead and do that. But now they have a common denominator. So I'm just going to put them both over h squared. So I now have o squared plus a squared. But what I want to point out about that, o and a were the two legs in that right triangle. And if you square and add the two legs, that's the Pythagorean theorem. That's going to equal, that's basically a squared plus b squared. It's going to equal c squared, which is the hypotenuse. Which means I really have h squared over h squared, which means we've just shown that that whole thing equals 1. You're not going to have anything like that on the quiz, but it's just a really good practice to go through. I'm going to do the same basic idea for this one. Now, tangent is opposite over adjacent. Secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse, so this is hypotenuse over adjacent. But I don't want to have a fraction and a fraction, so I'm going to think of this more as division. So I'm going to keep the numerator the same. I'm going to multiply by the denominator, which means I can cancel those. A over a is just 1. I have O over h, which means I've just shown that the right-hand side equals sine of x. So go into part C, cosecant of x. Well, that's the reciprocal of sine. So I'm just going to put, actually no, I'm not going to put that, sorry. It is the reciprocal sine. So instead of opposite over hypotenuse, I'm going to put hypotenuse over opposite. That's over secant x. Well, secant is a reciprocal of cosine, so I'm going to put hypotenuse over adjacent. Just like the last one, I'm going to keep my numerator the same, and I'm going to multiply by the reciprocal of the denominator, which means I have a over o. That's the reciprocal of tangent, because tangent's o over a, which means we've just shown that that side is cotangent. So just a good application of what those rules are, proving that one side equals the other. Again, if you take Algebra 3, or I'm assuming pre-calc and maybe calculus, you're going to get into that, but it's just something that we could do now, so that's why we added it in. Don't worry too much about it.